ABB India. And for this, I welcome Mr. Jaspreet Singh. He's the sales director. And I also welcome Mr. Praveen. He's the digital officer lead of ABB India. So I welcome you both so we can have the session started now. Yeah, thank you, sir.
Yeah, thank you, Anupama. Good evening
Yeah.
and
Good
good evening
evening.
to all. Am I audible?
Yes, sir, you are audible. Yes, sir.
Okay. So I think a very nice initiative taken by you, and I think we are very new to the student chapter of CSIR. So I would say that in shortage of time, I would just brief that ABB being a pioneer in industrial automation and we're having solutions right from any small machinery OEM till automation of power plants and everything. So we can just give you a very brief. I think that whatever time is allotted, we will try to cover well within the time. So we will just start with a very brief, and in case anything is required, so we can have a detailed session afterwards also. So I think over to you, Praveen. Praveen, are you there?
Yeah, Jaspreet, I am there.
Okay.
Good evening. Yeah,
Yes.
Rishabh.
I'll not eat much time of yours, so you can start straight away. Thank you.
Yeah. Let our Rishabh share the access for me. I can share my content. Yeah.
Yes, sir.
Mhm. I hope you are able to see my screen. And
Visible now.
unfortunately, I'll not go with
Yes, sir, we are.
video
Yes, sir, it's visible.
because yeah, I can't go with video because my broadband is down. Rishabh knows that. So I'm with a hotspot. So I'll stick with audio only.
It's perfectly fine.
So
It's perfectly fine.
So good evening all. As Jaspreet told, it is really glad to be part of this initiative and maybe a 40 minutes or a 30-minute session with scholarly or intellectual people like you guys. So we'll see what we can do on what exactly impacting this industry, right? Because I have seen your subject like how automation is helping for industries or in industry 4.0. So here I'll say that already industry is changing and it is adapting industry 4.0, right? I mean, I can give you some examples. I'm not going to show any product or a solutions. I mean, I'll say details of that, but I'll give you certain case studies from the industry. Okay. I mean, I think I have included around 5 to 6 case studies, how industry 4.0 digitalization is helping industry to improve the productivity aspects or overall effectiveness, overall how we will improve the what I'll say ultimately it improves the profitability or the reliability of the whole system, how that is. So that we will see. So if you have any questions, as Rishabh told, end of the session we can have a questions. 1 minute. Why it is not changing? Yeah, I mean I'll not take much time about ABB. I hope all of you knows about ABB. So we are there for more than 130 years in the industry, and we are catering into utility and the main industries and transportation and infrastructure. And we have products starting from small. I'll say maybe um, most of you guys are familiar with ABB switch and small MCBs and everything to the robots and the bigger transformers and everything. Then we have so systems like PLCs, DCS, QCS, lot of systems. Then we have a service and software, and we have presence in more than 100 countries, and I mean across the globe we have presence. I'll just skip it. So we were part of, I think previous speaker was talking about the industrial revolutions, right? So we were part of that, we were contributing to that. And if you ask the first industrial revolution to the second, then to the third, the time spanning is changing, right? I mean, 100 years, 80 years, then 40 years. Now I believe in this industrial revolution, what we talks about the fourth industrial revolution, that may be again a shorter span, but the impact will be much bigger. For example, one simple thing, because of this COVID, just now I got a message. I mean, incidentally, I mean, when this session started from my baby's school, he's just 4 years and he's going to a new school by June. Then there is a message that it is not going to open, and please come up with a tablet for the baby. That is the impact, right? So now everybody is going for digitalization in our day-to-day life. similar in the industry. They are going with Industry 4.0. Whatever we speaks about IoT, or we speaks about artificial intelligence, or we speaks about machine learning. Oh, is it my volume is, it is not audible?
It is good, sir. It is good.
Yeah, okay. Okay.
It is audible.
We can hear you.
So what I'm trying to say is similar the way how in our day-to-day life we are using digital technologies. It starts from an ATM. There is a background noise. I think everyone needs to be muted, I believe. I don't know. Yeah. And the mobile, one of the greatest IoT device we are carrying, right? So everywhere digitalization or IoT is there. I won't go for these numbers, and I am part of industrial automation process industries. Okay, so in the process industries, it serves mining, metal, cement, paper, and food and beverage industry. And I am responsible for India, Middle East, and Africa. And my current designation is digital officer, chief digital officer. So these are the industry we are catering. And now directly, I'll say we have a collaboration with Microsoft, IBM, Hawaii, different systems to have a different solutions. And we are into connectivity to the augmented reality or the blockchains, boards, management, even cybersecurity. We were there in this space in all the aspects. So here, what we are doing and what the industries are doing, right? In industries, if you take an industry, industrial automation, or an industry as such, any industry, there are two things. One is the operations and one is the asset. In the operations, yeah, they go for the process optimization, operation excellence, lean production, operation visibility, a lot of things, right? That is on the operation. Then the other way, the assets like motors, switchgears, transformers, bigger machines, cranes, conveyors, whatnot, everything in that particular factory. So it is like we need to take care of all these aspects. So ABB, we have a combination like we have solutions which will help operations to improve the operations, and we have solutions for improving the reliability. The biggest challenge of industry is what? One is ultimately they need to improve the profitability, definitely. Then they will look into this operations and they will look into the assets. So in the operations, they always think about how optimum they can utilize their resources. It can be anything, right? It can be on the fixed cost like people or their utilities or the power, raw materials, anything. How they will be able to use minimum thing over there, how they can optimize. And the other way in the assets, the biggest challenge is day by day, it is getting aged. And how is the reliability for that? So they need to have a solution for that. So ABB is contributing to both these aspects. And we have a unique combination. We have a solutions which can give or which can help industry to optimize their operations, to improve their asset reliability. So the basic philosophy, what we will do is sense it. So today, the previous speaker talks about the PLCs and the sensors. Yeah, we have PLCs, we have DCS, we have sensors. So ultimately, we need to get the information, right? In Industry 4.0, the main thing is what? It is about the data. So we need to get the data. We need to sense the information. Then we need to control, like, okay, whether we can do something over there and we are acting it. Again, sense, control, and act. This is a loop. Any project or any, even we talks about any analytics, any machine learning, ultimately what? We are taking the information, we are trying to understand that information, and then we are preparing a control or any insight over there, then we are acting on top of that. So this is the philosophy we are taking in both the aspects. So it starts from, okay, there is a next slide. So I'll skip this slide. This is talks about, okay, what are the industry challenges? Ultimately, as I told you, productivity improvement. I believe you people are doing your PhD and professors are here. So the real industry challenges, few things you also knows that. But actually, if you come to the real world, the real challenge is ultimately what? It is not the technology. I won't say it is a technology. This is my experience. When I start my journey in this industry, I understood that, okay, probably we are very tech savvy after college, we go for technology. Yeah, technology matters. Ultimately, what we deliver with the technology for that particular industry, we have to aim on what is the result, right? Ultimately, everything boils down to how we will optimize, how we will improve, how we will help industry to go for an optimum. Whether you can use a simple technology or a larger technology or a big AI or a machine learning. So there should be a balance and how we will utilize that technology to solve any problem, any real life problem. That is very important. So either in terms of productivity or the capacity utilization or on the, what I'll say, collaborative facility. Previous speaker talks about the UIs and some other things, how we will be able to collaborate. That also makes sense. Yeah, we need to have the collaboration because it is normally in the industries, there will be departments, few industry, they work in silos and they have Excel sheets, they have log books and they will collaborate like that. But in this industry 4.0, now there are a lot of initiatives to even that to change that into digitalize and get all the information together to do the to do the analytics over there, because you know that there are technology available, right? We can have a different kind of data, not only zeros and ones. I mean, everything is like a image can be taken into, text can be taken into, real values can be taken into all these things. Take it and collaborate and work. And ultimately, this needs to go for a sustainable development, right? Carbon footprint, how we will be able to go sustain in this world. Then the more important aspect of all this digitalization is cybersecurity. Whatever solutions we speak, whatever we solutions we say that it is enabled IoT or an internet enabled, cybersecurity matters, and cybersecurity is very important aspect of that. And also industry is changing. If you see, I mean, I'm going to talk today about mining to a metals to the finished goods, like from where we will get the ore and how you will see about your, I'll say any steel, even in a lift or in your fridge or wherever you are using a steel, right? Even the plate or the mobile, how that chain and what are the use cases in that, or few examples where we are working on that. All these things are personally, okay, I'm also involved. It is in India itself, we have done a lot of things. So all these cases are, we have done here in India. Okay, so that we will see about that. How then one of the biggest challenge in industry is to get the talent, right? Because it's a new talent is coming out from the college. So the expectation, we are tech savvy, so the expectation is also like that. Nobody will like to go in a 20-year-old or a 25-year-old technology go and work, or where we will go into a control room. If you visited the control room, you can see that how that will be. So that needs to be changed. That needs to be, it is changing actually, how that will come over there, right? So that talent attraction and everything. So that is also we are talking about. Before going to the use case, how the industries, how we can categorize the industries. Like a partially automated industry means, okay, very minimum automation. Locally, okay, few PLCs and DCS available. Few places it is connected. And now in industry 4.0, we are largely speaking about collaborative and autonomous. And everybody speaks about AI, and it is a journey. I mean, if I am correct, in the most of the industries, AI, or even we say that we just started with the machine learning, not be in the sense, the whole industry I'm talking about, not only ABB. So everybody's aim is to go like an autonomous operation. But to go over there, there are different steps because we cannot directly go and implement any AI, right? We can't go and do any analytics over there. Definitely, we need to have the data. We have to have a different steps to get all this information. Without the information, without the training, without these things, will not be able to reach over there. When we talks about a digital twin, yeah, we can create a model, but how we'll get the information for that and how we will train that, all this matters, right? So in digitalization, the industries are going for an autonomous operation, but for that there are different steps and industries are slowly moving towards that. Everybody is trying to understand the gaps and they are filling out, and we'll see how that is. I'll skip this. This is about the value proposition. Because of the time, it's already 7 o'clock, so I'll just skip this. And this is a truth. 60 to 73% of the data, when we say that in industry 4.0, and this is the data is the new oil, but really the usage of currently available data is very minimal in industries, in the basically in the heavy industries. I mean, they have a lot of data, but we have 3 years of history and 10 years of data sitting with us. But what we will do, everybody is exploring over there. That is the challenge. That is the real work we need to work on. And what is a smart factory? And I believe you people are aware of ISO 95 standard, right? It's an industry standard. So we have a sensors level 0 or level 1 sensors, level 0 sensors. That is like a motor, switch gear, or the machines. Equipments are there, field devices. Those are connected to the PLCs. There is a solution for that. Then on top of that, the blue collar for the plan level, how to schedule that. Solution for that. On top of that, ERP, I mean, I'll say SAP, ERP solutions are on the level 4. Now we are talking about a collaborative operation center. So we are capturing in all these aspects, and I'll go to the use cases of each of these things. And Industry 4.0 or the digitalization will help in each layer of the organization in terms of real-time control or a situational awareness or a performance improvement for the CEO or the MD or the chairperson. He can really take his vision. I mean, when he's having a vision, right? He can really see how his assets or how his overall organization is performing for towards his vision. So those can be enabled easily, or that can be enabled much better with Industry 4.0. So the first use case is an IoT device. You can see an image here. This is a small IoT device, which is I'll say size of a small mobile. When okay, it may not be a size of a bigger mobiles, whatever it is coming right now, but okay, a medium size mobile size. So what it can do, this is an IoT device. So see, this sensor can be affixed with the motor, low voltage motor. You don't want to do anything, you can in a running motor, okay, you go and attach with that. This is having an IP address, this is having the connectivity to the cloud. It will monitor the vibration. It can tell you the bearing conditions. It can give you the operating parameters. It can give you the notification. Ultimately, what we are going to do, we are doing a prediction when this motor can fail. Is there any problem? So this is a predictive maintenance. It is an IoT. It can pull the value from this motor without, it is developed from our corporate research here in India, and it is inaugurated by President Obama last time, I mean, a few years back. What I'm trying to say is that is the way the industry is going. So this sensor, simple sensor, you affix it, it collect the information, it push this value to the cloud, and the users will be able to see this. So the data security, privacy, everything is managed, and it's a subscription. So it's a simple thing.
Hi,
So similar
Praveen.
to, yeah,
Hi, Praveen. This is Kunal. How are you?
yeah, tell me.
Praveen, I just wanted to ask you in this smart sensor application, what you were telling us. Is this an external sensor that is mounted on the motor surface, or is it an inbuilt sensor?
No, it is an external. We can go
It
and
is
we
an
can
external.
affix it externally. Yeah.
Right. So this external sensor is mounted over the motor frame. This is what I understood with what you were telling.
Right.
The sensor is mounted over the motor frame, and it is sending the data, for example, the surface temperature and vibrations produced in the motor.
Right.
But you just said it is also sharing the parameters of the motor. So how come the parameters of motor are connected with this sensor?
See, we are a motor manufacturer.
Uh-huh.
So few of the parameters like a start, stop, and the temperature,
Mhm.
those informations, there is an algorithm. It is a patented with the vibration, with the condition. Few
Mhm.
informations we are taking it and we are showing it, or we are taking it and we are pushing to the cloud. So I can take you to the details. Even I can send you the brochure or catalog of
That is
this.
fine, but you
Just
said the parameters of the motor are also shared. On what parameters the motor is running. So how this sensor synchronized with the motor parameters?
that's what I'm trying to say. I mean, probably I can take this into a detailed discussion with the
Uh-huh.
colleagues and we can take it up. Okay. Is that
Yeah,
fine?
Kunalji, just please this side. Actually, your first question, whether it's an external, so the right side picture, that white device, what you see is that the smart sensor which is installed on the motor body. If you can just
Right.
predict how it is installed. So mainly there are three these sensors also. So x-axis, y-axis, and the third in three-dimensional, we just need to have it aligned while installation. And second is basically it is all algorithms. That is our basically design strength, what ABB has. So based on this, it is totally non-wired, nothing, there is no wire, there is no recharge of the battery, nothing. It is just once installed, forget fit and forget type of a thing. So plug and play device, what we call. So it has an inbuilt battery which lasts about 5 years, 6 years, depending upon the ambient condition. So if it is very high, very humid and something, so it might 1 year gets reduced, or optimum life is about 5 to 6 years in normal conditions. So based
Right.
on that, you can get what is the loadability in the meter, at what speed the motor is rotating if it is operating through VFD. So you will get everything on, basically inputs are your vibrations, the alignment at which it is installed, and third is skin temperature.
Right. So, Jasprit, I really
I
understand.
would
I
just
really
add,
understand. Sure.
yeah, yeah, please
Please go
carry on.
ahead.
Okay, so based on that, three, four things, that is our technology, what we have put in. So that results, if you will see even temperature of the winding, what we are showing on your app, basically either mobile or computer. So the accuracy with a normal infrared thermometer, or you may say laser thermometer, accuracy is close to 99.9%.
Uh-huh.
Yes.
No,
So,
Jasprit, my question, I really understand. I really understand this, but I have also used this similar kind of applications. I've worked on this similar kind of application. Why I'm asking is, I was thinking if there is something new that ABB has introduced which has a synchronization with the parameters, the running parameters of the motor, which includes the voltage, the current motor is drawing, the frequency on which motor is running, the torque, what motor is delivering. I was considering that this sensor is also synchronized with these parameters
yes,
and
it will
giving.
give you, sir. It will give you, like you are running at say 35 hertz, and it's a four-pole motor. The RPM are 1000 instead of 1440. They will give you, this sensor will give you the output at what RPM the motor is running at present. And even the loadability it will give you. For example, you have installed a 30 kilowatt motor, but your
Uh-huh.
running kilowatt is too less. So it will give you that how much percent it is loaded also. That also value it will give you.
All right, so is it a
I
multifunction
think I
sensor?
think if you just share me your contact details, I will forward it, because this will take it very long. And
No problem.
it is not only motor sensors. We have now sensors for the pumps also, which will give you the bearing conditioning of the pumps in the similar way. No wire, nothing. You just installed it on the pump body, and it will give you all
Uh-huh.
the operational parameters of a pump also. And it doesn't limit to pump. There are small tube type sensors which we call as smart sensors. They are
Mhm.
there for normal bearings also, like mounted bearings we use in industry. So we
Right.
have that condition monitoring of those bearings also. So you just share us, sir, some details, or we can give you our contact details. We can give you that brochures and take this discussion into more detail offline.
Yeah,
Right, no
because it's a
problem. I
live
will
discussion.
just.
That's why I try to, yeah, that's why I try to take it. So, I mean, probably this, I mean, we'll have a detailed discussion. Kunal, it is better, right?
We
Shall
can
I go
show you,
ahead?
sir. We can
Please
show
go
you
ahead,
the live
please.
demo on your mobile also, sir. On remote session, we will keep a 15-20 minute session, and we will show you the live demo, because these sensors are installed already installed in our factory.
All right, no problem.
Sure, sir. Thank you.
Thank you.
Praveen,
Thank you
carry
so
on, please.
much.
Thanks, Jaspreet, and thanks, Mr. Kunal. Yeah. Okay. This is a, I will just keep this. So now we have seen, okay, there is, okay. Yeah, it is actually not a stockyard. 1 minute. I think some issue. Okay, no problem. This is actually an asset management solution. So we have seen about one sensor, right? One IoT sensor. The similarly we have for switch gears and we have for transformers. So we have a different sensors for that. That is fine. But now if you ask about an industry required not only motor is available, not only switch gear, right? A lot of other mechanical assets are available, like conveyors are available, crane is available, concrete are available. So how we'll do the asset management over there? So right now, everybody talks about predictive or a prescriptive maintenance. So to achieve there is a solution. So what we'll do, we will collect information from all these assets, and there is an asset library and asset models. So we have a digital twin for few of the assets, which we are right now around 60 to 70 type of assets we have as a digital twin, digital data twin. So we can collect information from the industry, I mean from these assets from this industry, and we can provide, and this reference is actually like one of the largest uh, mining complex. Okay, so there are more than 6,500 assets we have connected into a single platform. So what I'm trying to say is, see the digitalization impact. So we are connecting through wireless and few things over wired, and all these assets are coming into a single platform, like a horizontal integration. Then this will give an insight, each of these assets health index, and that particular area's health index. Then they can drill down and they can see, and they can go for individual root cause or a fault tree analysis of this of these assets. So this is the way we are moving. I mean, the industry is moving. Okay. And once we have enough data, few things, okay, we are already moving to the predictive maintenance, few things we are on the condition monitoring. So that continuous improvement is happening. So that is on the mine I told you, right? So we are getting the information. And this is another real, maybe this is an interesting, much more interesting case study, or which we have implemented in one of the largest steel plant. The raw material from the mine will come to the JNPT port. And from Mumbai port, they will transfer this ore into their plant. And then they will consume this raw material and they will work on that. So what is the problem here is, in the JNPT port, the escaped vessels or the mother vessels will come. And there is a time for a 2 days or a 3 days time. After that, there is a demurrage, there is a clock. Whenever it delays more than that particular agreed period, there is a demurrage charge will come. Based on the time, how much we have carbon, how much they have consumed. It's actually a huge cost. So they need to optimize that. It's a logistics problem. How they will optimize that? So there was a problem statement. So then we were working with them. Then we understood it is like how from the first thing is we need to understand when the ship will come from the maritime. Okay. Then we need to understand the schedule, how they will get the dock to keep this vessel over there. What is the schedule of that? Then from that ship that need to be unloaded into the barges, the smaller, I'll say it is a smaller boats or vessel where they can carry the raw material. And through the barge, it will come from the port to the steel plant through a river. Okay, it needs to be over there. Then the stockyard or in the port, there is a GSUs where they will unload it. Then it will go to the stockyard area. From there, it will go to the respective processing area. This is a steel plant case. So here multiple things are available, right? So you see the complexity. We need to understand maritime information. We need to understand the high tide and low tide, because whenever the high tide only, then only this barges can come through the river. So we need to schedule with respect to high tide. Then we need to understand availability of the. Okay, it's okay, right? I mean, if I am going a bit detailed, you can always tell me. No problem. We can quickly go. We can quickly wind up. No problem on that. Okay. So here in
Not an issue,
this.
sir.
Yeah, so here see the way how it is coming, right? Because maritime information, high tide, low tide information, then we need to track those barges. Then we need to understand the availability of the equipments to unload this, space in the stockyard, and which material, more than 60 type of material need. Then which type of material is required immediately based on the planning. So it is, the whole thing is related to the complete production planning, and then hold all these barges. There are more than 40 barges. So we need to schedule it. And there are a lot of constraints for this. So with all these things, we need to optimize and we need to reduce the turnaround time of a barge and the ship. So this is what one of the things we deliver. So here the important thing is, see how we are utilizing the technology. The thing is, we are getting from the public information, we are getting this maritime plus tide, low tide, high tide information. And we need to understand from a port how they are shipping for the docks. And then there is users, brokers available in the port. And they need to say that, okay, this is the ship is coming, this is coming, this is coming. Some updates through the internet, we need to get it. Then we need to track the barges. So there is a tracking device in the barge. So we'll get the real-time information of the barge. Then we are connected with all this conveyor and the stockyard equipments. Then we are getting this information. Then how we are optimizing based on the production schedule. So this is a larger problem. So that is what right now we are sold, or we are working on. It's already sold actually. So this is the power of digitalization. Probably 4 years back, whenever we think about it, we think twice, or 5 years back, okay, how we'll do the technology. I mean, we say that, okay, technology is getting mature, and people never probably think that, oh, okay, maybe it is impossible. A lot of things will come up in picture, right? But now technology is available. With this technology, with this IoT devices, tracking and scheduling optimization engine, we are able to work in a larger scale. It is like a bigger one. We are working on that. So now we got the motor, we have seen the asset, how it is, and how the raw material is coming into a plant, to a factory. After coming to this raw material, how we can improve the stockyard, right? You know the stockyards. If you know the mining industry, or a cement industry, or a metal industry, stockyards can be from a 250 meter to a 500 or 800 meter, 1 kilometer long stockyards. Million tons of material will be there. So the constraint here, what it is, they need to utilize that. So, and they need to get the information about this stock information. It is just like how we will see. We will see the metal, not metal, like boulders in the roadside, right? We will see that, or the sand, how they kept. These are smaller chunks. But now imagine million tons of material across the yard, and they need to understand, when I got this material, what is the quality. The problem with coal and all, if coal sits for more time, it start burning, there will be fire inside, and this smoke will come after few days out, I mean few hours. By that time it will burn and it will come to the ashes. And the quality, and then they need to utilize the space in the stockyard. They need to see the space, right? Because that is also money. So how we will be able to optimize that? This is a problem. Yes, there is a solution for that, stockyard management solution. So in the stockyard management solution, not only mapping those materials, we can go, this is actually, there are two ways to map that. One is we can do a algorithm. We have a mathematical algorithm, a cuboid model, based on the volume of material coming up through the conveyor, from the ship through the conveyor. And these are the bigger machines, big gigantic machines. You can see that even these videos are available. Whatever things I am talking about, everything is publicly available. You can see the videos and everything. Because I can't play the video right now through the internet, that's why. Because maybe it may not be the, it won't give you the right effect on that. Okay, so this is a gigantic equipment. Then through the conveyor, it will come and it will pour here, or they can take it out, stacking and reclaiming. So mathematically, we can calculate how much, I mean, how much material we have taken out. And there is a correction factor. Other ways, we have a laser scanners here and a GPS coordinator for here. Even one of the Malaysia case, what we have done is in the Valley, what we have done is for the coordinator, even we have a, we will get a small GPS, a radar actually. We will get a radar and we kept over there, then we are tracking all these equipments. So there is a mathematical model, algorithm, plus a physical tracking of this. Then we know if in India we are importing material from South Africa, Chile, Brazil, Australia, Indonesia, wherever, there is a different quality, okay? So we'll come to know that in these big stockpiles, where exactly my material is there, when it came, how much I have reclaimed, what is my total material balancing, how much I have utilized, how is that? So those information we will get it. Now there is an autonomous machines, like nobody is there in that machine, everything will be controlled autonomously. Nobody, it is manless operation. So there is a solution available for that. And some of the industries, even some of the countries, they are going gradually with the stockyard management, just get the visibility, then move towards a remote operation, then go for an autonomous. Yeah, there is a cost in between. So it is a trade-off actually. How we will give the technology, how much big it is. Definitely there is a trade-off on cost. So based on that industry or based on that particular customer, okay, we used to work with them and we'll identify how we need to go for that. So you see how the things from the mine we got it. Then now we know exactly from where it came, which depth. This is like a bigger, I mean, it is like more than 10 meter, 15 meter height piles. And in that, we know that each of this material, each cuboid, 1 meter cube, from where we got this material, what is the quality of that material, and where is the money? The quality, because based on this quality of the material, my steel or whatever I am producing, that makes sense. Even the coal, because they need to mix different qualities. For example, a simple example is if you want to make a what I'll say, the sweets or lemon juice, right? So we have to pour the properly the sweet and propose and the salt, like blending. A proper blending needs to be done. So here also, if customer want uh, a quality of grade A, which is having 98% of all quality, so they will take like something from South Africa, the good one, and something from here, and they will mix it and they will keep exactly at the 98. If it is going more than 98, it is a loss for the company. If it is going below 98, it is a penalty, right? So that is the profit. So that is the benefit they are going to get it based on this technology. So I won't go for the individual functionality, but more or less this is what the stockyard management will do. So now we got the raw material. So now I'm taking an example of steel plant, okay? Because more or less cement and paper, okay, it's a similar way we have. So I'm just taking an example of the steel plant. So you got material up to the this one stockyard. Then you have to process this. Like you need to make a steel out of that. So blast furnace will be there, pellet plant will be there, a lot of heavy equipment, heavy mechanism will be there. So in that, lot of utility will be there. That utility can be a lot of coal and nitrogen, special gases, nitrogen, oxygen, argon, a lot of things, power. So how we will manage this utility? So there is a utility manager. So here the important thing is, if you want to get all this utility information, these plants will be like a 5 square kilometer, 10 square kilometer, more than that. This spread across. We need to collect all the information together because all these things are different. And not only electricity we are collecting, we are using the sensors to um, find those gas analyzers. We are utilizing it. All these things, all this sensor information will come. We'll get the production information. Then we will schedule it. We can forecast, okay, based on your production, this should be the consumption and this should be the pattern. So if it is moving, we will give an early indication to that. So we are doing the forecasting. A lot of things. Even if you are taking the electricity, there is a concept of maximum demand. In each 15 minutes, they need to come up, they need to be in that particular maximum demand. It is same like our slabs in our home, but this is on the 15 minutes for the industry. So they need to keep it that. It is a 900 megawatt, 1000 megawatt or 30 megawatt based on the volume of that particular industry. So they need to keep in that particular band. So if it goes more than that, again, government will penalize them. So how they will balance it? And they have their own captive power plants. So how they will balance between from the grid and from the captive power plant is actually a superb machine learning algorithm. So what we'll do is not only that algorithm, so it is having a lot of real-time information. Everything we will take it, and based on the schedule, on the current process status, we work and we will forecast it. Okay, if you go this is the way this can go. So you think about it. We are not replacing the human over there because human have the capability. But if it comes this much information together, we will be able to process much faster, and we can really give the indication. We are not talking anything on the replacing somebody. No, but you imagine the operator, how much he will be relaxed. Otherwise, he's getting a lot of information and a lot of things he's not able to do. And he will be able to do up to probably a 95%. But by the system, we can go to 98%. That is a huge improvement. Okay. So that is what we are doing on this. And this is okay. This is one study what we have done, something with random forest we have done. So I'll just skip this. This is basically for the special gases like argon and nitrogen and oxygen. How we'll be able to show some value for an hour, how we'll be able to save it. So now we have all this utility. Now we are preparing a steel. If you are familiar with the steel plant, this is one of the biggest power consumer in the steel plant or a steel processing or a steel production. This is a melting shop, steel melting shop. So there is a converter big furnace. From the ladle furnace where the additives and the grade end will be coming. And this is the caster, whether it is a slab or a road or a whatever it comes out. So here what we are doing is, this is actually a biggest challenge for the steel manufacturer, and it is really very harsh environment. If you go there, the steel will melt at 1550 degrees Celsius, 1550 to 1600 degrees Celsius, and these ladles can carry 200 to, okay, some places it is fine, 50 ton based on the steel plant, but the bigger plants carry 200 to 300, 400 ton molten material. It is like a orange juice. It is like a molten metal. And the cranes will carry from here and it move to here, sometimes transfer cars, then again process and it will go and it will cast it. And the environment is really, really dusty. That's what I mean. Now I am remembering when we say about a battle, we say chess, a game, right? That is also a battle. There are rules. We know that how to move and everything. But the real battle, there is no rules. Correct? It is complete uncertainty. A lot of things can happen. Anything can happen. There is no rules. That is the real difference. When we are doing inside our lab, even okay, I'm also part. I mean, I was part of the CRC, so some patents and some of this stuff. Even for this project, I have a patent. But what I'm trying to say is when we think in a room in the lab, we have certain rules, we can imagine something, but we go to the really in the plant, it is really like battlefield, like anything can happen because the main priority is to come out this material and go and cast it. So whatever rules they say that the operator will change the rules. So here what we are doing is here it is like a simple concept is like a Uberization of small melt shops. Like multiple cranes will be there, multiple transfer cars will be there. This ladle needs to move from here, 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 and everywhere. So if we are able to track all these devices, we will be able to get a certainty like, okay, I know that, okay, this process is going to how much this time, and it will get at this time, because at a time, more than some of the plants 18 to 20 ladles will be there, like they have a similar kind of 4 furnaces, 5 ladle furnaces, 4 casters, or 5 casters, depends on the capacity. So there you imagine how many bigger equipments and how the ladles are moving, and people are really really stressed and they are working. So we are tracking all the things. So here we are using radar to track the some of the things, laser we are using image processing to see. And the real thing is, whenever they pour the molten metal here, there will be a heat dissipation because heat will go out, right? It is 1550 degree. Then if you are able to predict if this will come at 10:15 here and it will process for 10:50, 40 minutes, it will process. Then it will move to caster, but caster will be available at 11 o'clock. So there is a 15-minute is there. So normally in that 15 minutes, there will be this 1560, they will is superheat they call. So if it is 1560, if I keep for 15 minutes, there will be a dissipation. So the quality and some of the things will not happen here. So operator, what it will do, he will do for a 1580 or whatever that the range is there, plus or minus range they will keep. It's simple like a coffee. If we keep coffee over there, we don't know after 10 minutes if come, it will go cold. But if you come 5 minutes, okay, that one. So if our mom knows or wife know that, okay, this guy will come after 2 minutes, so he can keep that, she can keep the optimum temperature, right? There is a dissipation. So after 5 minutes, okay, she can keep accordingly. Exactly the same thing. So there is an algorithm. It's a first principle algorithm. So we will calculate based on the properties of the steel and all these things, all these times. We know exactly at 11 o'clock it will be there. So how much extra he need to heat here. So the whole thing is, if I have a 200-ton molten material, if I need to take it to 4 degrees Celsius, they need to arc for 1 minute. It is a huge power, electricity they need to use, the huge power they need to use. So even if you are able to reduce a simple 5 degrees Celsius here, if instead of 1580, we say that no, you will reach by 1055. So don't go for a 1080 degrees Celsius, 1580 degrees Celsius. Go for 1575. That is actually a saving. Plus the time they will save, plus all the visibility, how that will move. So this is the technology, right? I mean, for us, this is like, see how digitalization is changing. Maybe previously all these things comes together, the applications, theory. Now that theory is coming into the practicality because everybody is moving towards, yeah, digital things. Okay, we can collaborate, we can use all these sensors, this can communicate, there are algorithms, we can utilize that. Okay, so this is, so now we prepare the steel. After the caster, this will go to the processing, like whatever you see, like a TMT bars, or it can be like a sheet for the fridge or whatever. So here we need to understand. So I'm giving different examples. Okay. So from there we have done. Now we got this sheet and everything. Now what we will do? We need to understand the defects. One of the use cases. Now you have seen that how we will optimize the production, right? Now we see the defect, how we will go to the quality aspects. So if I know the parameters of my previous process, if I know the what is the current process, the next process, if I am able to correlate and if I am able to say that there can be a defect, it will be a fantastic thing, right? Some of the experienced operators say that with few parameters, they say that, oh, okay, probably if I do this, maybe that there can be an error. But now you imagine there is a system which will take which are the relevant parameter, because at a time 2000, 5000 parameter will be there. So we will identify which are the relevant, which is the major actor or bad actor which is contributing. Then we monitor that, and there is algorithm. This is actually a random forest. Then we'll come to know, really, like in our what in cricket and all, we say if this guy has done more than 50, the probability to win this team is more, or this guy got this much wickets. Okay, this one. The similar fashion. Now I'm just simplifying. So we know that if this parameter goes this, and by that time that guy is doing like that, multiple scenarios, then what is the probability for a defect? The similar way we are doing for paper also. I mean, basically on the defect aspect, how we will be able to predict the quality aspects based on the current machine learning algorithms which is available. Here, the important thing is, one is these algorithms, data scientists, everybody is available. We need to know the domain knowledge also. We should have a domain knowledge, right? I need to understand, because lot of anomaly, lot of what I'll say, these outliers will be there. So we need to understand which are the things. So it is a co-creation. Some ABB have a domain knowledge. So we have a data scientist. Sometimes we used to work with our customers, our operators. We'll understand, okay, how they are doing, and few things, and we will tune it, will come up. So this is another application, how industry is utilizing the algorithms to have a defect prediction, how they are forecasting it. So we prepared, I mean, okay, until now we speaks about different things. Now I speaks about how machine vision help for an industry. So again, so as I told you, this is a TMT bar. So in TMT bar, the simple example, I can tell you that, okay, this will come, then we need to count it, how many bars are there, because they will make it as a bundle. So in a bundle, they say that 100 or a 102, 108 or whatever the number. So this will come very fast, and everything is automated. So we need to count it. A simple example, we can use a camera, and we can do a video analytics over there. And in this, there is a defect, we can find out. If it is a sheet, any defect, we can find out. And not only this, in the safety aspects, if somebody comes over there, we can. In surveillance aspect, we can do. So what I'm trying to say is, it is a technology and how we are utilizing it. It is an enormous opportunity or enormous possibility. If it is a conveyor, we will say which is a foreign body. So what I'm trying to say is, here we are utilizing the machine vision or a video analytics for this, or a thermal imaging. Okay. And now I'll come. We have seen, okay, the TMT and everything. And as I told you, now this is one of the good example, like we are chatting over WebEx, and we are sharing our knowledge and everything. The similar way, if customer have a problem, how we will be able to solve that issue, right? So he is doing a field activity, how we'll be able to do. So here we say augmented reality is one of the big things. It is not only for the remote assistance. If you see here, she is wearing this is actually a real wear glass. This is a smart glass. Whatever she is seeing, the expert in the remote location is seeing here. Then if you see here, there is an annotation here. I think I have put one more slide. So there is an annotation, and he can share everything, and she can see here. It is an augmented view. And she can speak, and at a time, three guys can, at least in the current version, what we released right now, we can have three experts together across the world, and everybody can see what she's doing or what the field guy is doing. We can support, we can share document. This is how we will be able to reduce the turnaround time to attend a failure. How we'll improve our response time. This is what the perfect example of the digitalization, right? Augmented reality. And what next? Now we are doing the remote insight, or a remote assistance here, remote expert assistance. And now imagine she is doing, she is a technician, and she is doing a maintenance of a transformer, and we can load a 3D model, a digital twin, and it can get the information. It can give one by one instructions and everything, how that it is a combination of a 3D model and the instructions. So she can do it herself or himself. And the training aspects, somebody want to get trained. So all these aspects are coming in AR, VR. And this is actually, here you can see this annotation and everything. This is also actually a released one. And now we have seen how we are supporting, how we are getting the complete value chain, how the service and everything. And the other thing is like a collaborative operation center. Like ABB is coming up with a collaborative operation center. So here, whatever we have seen today, all the, including the motors, from the motor sensor, Even we have robots, we have chips, some ASI ports, a lot of things. Everything, all these things can be monitored. We can enable a remote monitoring into that. And we can monitor remotely from our ABB office. Data is secure, there is a subscription, everything is secure, it is private, fine, but we'll be able to collect all these informations, and we can also be part of the day-to-day operations of the factories. We can give our global expertise, our guys together to work with them. We'll try to give them an optimized way how that can be, because in the normal the operations they are completely busy, right? So we can supplement that. So this includes analytics, operation support, predictive maintenance, optimization problems, cyber security, and the control and all the things. So that is the new thing we comes up with the collaborative operations. So even ABB is helping some of the customers to set up their own collaborative operation centers, like a large scale integrate, everything comes into the same place, different application, different how they will communicate and everything. So this is from my side. So I hope, even though the time is what, okay, 7:36, I hope I'm able to share some of the use cases with you, how industry is moving towards Industry 4.0. Yeah. Any
Yeah, thank you,
questions?
sir, for a very fruitful session. Yeah, so we can take up some queries of the participants. So we have one in the chat box from Anurag Chaudhary. So I'll read it for you. Have ABB released any product for estimating the remaining useful life of rotating components?
I mean, rotating in the sense that the motor and motors, right? Okay, probably, okay, I can come back that. Okay, what is the remaining life? I believe it is the maybe just for the motor sensor and the motor or our MaxSense. Can you add something here?
Yeah, I was also thinking means what is rotating component means it is some gearbox, some motor means what is the rotating component meant here? If you
I
can
want
just
to ask.
clarify, so it will be answer can be more specific to that.
Yeah, Anurag sir, you can directly unmute yourself and directly interact. Yeah.
Okay, thank you. Sir, actually, I want to ask about the rotating machine, like bearing related issues are there or rotor related problem are there. So how can I
Okay, so
find the
anything
remaining?
okay, so anything you mean say rotating component. So sir, in a machine, what we can see is that either there can be a shaft which will be mounted
Yeah,
on bearings on either side. It can be a blower shaft or it can be any machine shaft. So for earlier also I told that there mounted bearings on both the sides. So we again have smart sensors for those bearings. And ABB might be you know it as a electrical company or automation company, but I would also like to add we are into mechanical power transmission also. So we are very high quality mounted bearings and gearing solutions, even conveyor solutions under the brand name of Dodge. So it's a US company. Totally, our all manufacturing setups are there in US only, and from there we bring this family where we have a very high quality mechanical power transmission systems. So,
okay.
answering to directly your question, like remaining useful life. So, I would not say remaining useful life. I would just say that these smart sensors, whether as explained by Praveen for motors or pumps or this, so they are we collect data and we set some warning points. As there are some warning points approaching, so these smart sensors will give you prior information that there is a likely chance of failure, which you can timely address to, so that the failure doesn't happen, the downtime in the machine doesn't happen, and very timely preventive maintenance needs to be done, so the machine is always up and running in a very efficient way. So hope I was close to your answer question.
Yeah, I mean, probably, yeah. I mean, we are giving like at present condition. So precisely for okay, how long it will run. That anyway, maybe I mean, I also need to check exactly if you ask that, okay, how long it can. So there is a running hours. We are counting the running hours also. So, but maybe just please, we can also take it up. And we can talk to Kachetan and we can try to get back,
Yeah,
right?
so in that case, we can take an example of motor. Like there is a bearing, 40,000 hours is the life. So if from smart sensors, operational hours are coming up. So when it is approximately touching 40,000, so that can also give you an intimation that, okay, the bearing is now needing replacement. And present scenario, a user comes to know when already the bearing is gone. There is a short in the motor needs rewinding. And once the motor gets rewinded, again the efficiency goes down. So to prevent all these failures, these solutions are coming up.
I think, sir, this is all about the predictive maintenance, maybe. Uh,
Right, it is predictive maintenance. So the thing is the predictive maintenance. Okay, we say predictive maintenance, right? But everything is evolving. What I'm trying to say is most of the time, what is holding back from the predictive maintenance is the lack of data. Okay, for motors we have a data. We are doing up to certain extent on the prediction, but few other things we don't have the history really to see, and the operating conditions that also vary up to certain extent, right? So if I have a motor in one place or something in the crane, so a lot of things are depends the vibration, lot of things. So even some of the patterns we need to analyze based on the operating condition where we are keeping. So it is an evolving thing. Honestly, if you ask me, if somebody say that I have a fully predictive maintenance solution, maybe I challenge normally, because we also know that okay what we are doing, right? So condition monitoring is completely available, and predictive maintenance, yes, more than a 60 or a 70% it is going. So that is in the market, I say. Somebody say that it is not 100% or a 90%, I say. Okay, that it is a predictive maintenance only. We are in that journey.
Sir, I have another question is, sir, what's about the infrared thermography? Means you are dealing on the vibration monitoring. Yeah, you have some product related to the infrared thermography. And what's about the reliability of thermography?
You mean thermal imaging?
Yeah.
See, just because I'm not sure we are dealing with any thermal imaging cameras, because my projects I used to buy from.
No, no, I'm not
We are not
asking about
manufacturing.
the
No.
thermal camera.
Okay.
I'm asking about the some maintenance solution with the using of this thermal imaging technique.
Okay, so you say that the temperature, okay, you see the temperature and you say that okay, this temperature is high and how that is, right?
Or and how much it reliable with compared to the vibration.
Uh, I don't know. I mean, if you really ask me honestly, I mean, for me, some of the places, most of these things, we are relying on the vibration, honestly, and where we are relying on the thermal imaging, thermography is. I told you about the ladles, right? Where there's 1560 and all. So actually, that is one of the project going on. Like with the thermal imaging, we'll be able to understand the heat spot, hot spots, and everything. Okay. So
Okay, sir.
in my experience, probably I'm not the right person to answer you that, because I'm also exploring that, because I'm working on that. I don't have the result yet, but you're right. For the equipments, at present, we are much relying on the vibration sensors. We are getting the vibration information. We are trying to do the things over there, not much on the thermal. Probably there will be some good thing. I don't know. Honestly, I don't know.
Okay. Also, ABB have released any motor fault data. Like I have a develop an algorithm for with the vibration or like infrared thermography data. So how can I test it that particular algorithm on your data?
Yeah, there are okay. We have a certain agreement. Okay, I mean, even maybe today before this call, I was talking to Jaspreet. Actually, normally we used to uh, collaborate with universities and professors and colleges, so we can have a collaboration. There should be some NDA. There is a procedure. If you want to do that, we can collaborate. We can think about that, and I can probably I can get you the right contact to do that. So then we can take it up. Like what you can contribute over there, how you can contribute over there. There is a mechanism, because we used to collaborate with institutes.
Okay, sir.
Because all the data what we speaks, there is a what I'll say. There is a what I mean. It is a. I mean, one is okay. I cannot take the customer data we have. So there is a novelty and there is I forgot the right word. Okay.
Okay, sir. Okay, thank you, sir.
But you talk to Rishabh and you can get the my email ID or the contact. So I will help you on that. Okay, to get the right contact if you have something like this. even Jasprit, I don't know, either through the CRC or Prasanna can give some insight on that, how if they have something like a student project or like how some of the things, how we can take it up.
Okay, sir. Okay, thank you. Thank you so much.
Okay, thank you so much.
Yeah, to the best of my knowledge, I think ABB was setting up some lab in CSI or CSIR if you can have access to that. I think last year something was happening from ABB side. And it was related to automation, means exact details we don't have, but still you are there already in that campus. So you can just check with them.
Okay, sir, we'll check with that.
Okay.
So our team was there in CSIO last year, I think. So some big project was going on that I could say out of our CSR activity. Yeah.
Okay, sir.
Okay.
I have one. I have one question.
Yes, yes, please go on.
Rishabh is asking.
Okay, should I? Okay. Sir, I
Will
have
be
one
able to
question.
wonder
Actually,
this yeah, please.
uh, actually, you mentioned about water quality monitoring sensors somewhere in the presentation. Uh,
Not water.
should
I'm
I?
talking about the air, I mean, analyzers and air, right? I mean, I'm talking
Air
about
analyzers.
utilities. Yeah, different utilities. Yeah.
So, I would like to know that you are manufacturing or making those sensors, or you are procuring them from other companies, just
Few
and
things
using
we
it
have
for.
we have a different business unit. They are making few of the analyzers, and even we have some of the meters and everything, and few things we are taking from out. Okay, it just depends on what we have and what we don't have and what is the requirement.
Okay, thank you. Yeah,
Hello.
Miss.
Yes.
Yeah,
Devin. Hello.
I can hear you.
So we can hear you.
Hello.
Harihar Saab, we can hear you.
Yes,
Yes. Sir,
Mr.
I want
Parihar, you can speak.
sensor you are using, which is mounted on the motor. It is a active type or passive type.
Active or
Here
passive.
you need, yeah,
Type of sensor you are using.
Jasprit, it is a Jasprit.
Yeah.
Are you there in the call?
Yes, I am there. I am there.
Yeah, I mean the question is like active or passive in the sense, okay, continuously or how you are getting the information. That's what you're talking about, right? It's like active and passive RFID and some other steps, right? Is that the right question?
Yeah, kind of. Yes.
Okay. So, Pariyar sir, this is a sensor where we take, in generally, we are taking a reading after every 2 hours. So, but depending upon the criticality where the motor is installed or the application, so this can be again customized. Might be you need it after every 30 minutes, 1 hour, 2 hour, but again, it will impact that battery life. That is the only thing. So depending upon condition, how soon you want the fresh figures from that motor sensor, we can do it.
Okay, that means
And
it
okay,
required a power. It's a kind of active sensors.
it is an
And
active one in
and
the
this
sense. Yeah.
sensor is connected through Bluetooth with your smartphone. So about 7 to 10
This is
days or 15 days data is there. Pardon?
that means active sensor with a wire transmission. Okay.
It is
It
totally
is like
wireless
this.
with respect to motor, and it is totally wireless with respect to your mobile from where you have to take the output of that sensor.
Okay.
There are two
My
ways
next
here.
question is,
I will add to Jasprit. One is with the Bluetooth of mobile, or then we can have a gateway. So that gateway can get the value through Bluetooth from these multiple sensors together, and it can push to the cloud. Okay.
okay. My second question is, strategy to handle a false prediction. If your prediction is false, if you are using machine learning, your model can predict there's a negative, false negative is also there. So if it is predicting false, then how you are handling this false prediction?
This is in case of the motor sensor you are talking about, or in case of the in general our analytics what we are talking about?
Any case study. If you are
Normally,
uh, predicting motor and whatever in a then
Niranjan, just
how you are handling, how the
there are anyway we have the learning and the rules are already applied, right? So the outliers and the some of the steps anyway we are eliminated. So that is anyway taken care. If it is a case of motor, the guys really knows not only the data, they know the physics of the motor because ABB is a motor manufacturer. So the team they really knows even like what can be. So not only a simple data, there is a physics behind it. So they know the physics as well. So accordingly, we are taking it. Okay, so the outliers and everything is handled inside the algorithm.
so here I have all the information regarding its physics, then why we are not taking a logical decision instead of machine learning? That means if we know if the condition is greater than this and less than that, then we can take the counter action. Then why we are not taking here instead of going to the machine learning for the prediction?
I hope they will be because I'm not part of that, or probably, I mean, I don't know. So, as per my understanding, the team who has developed that has
Okay.
taken care of those things. Because normally, you know that, right? Before we go for the live, we have offline modeling, then we will take it for the trial. I mean, we'll go for the things, then only we'll take it, right? Multiple things. So, definitely, those things should have taken care.
Okay. Thank you.
So going to our last question of the session, I request Shrey sir to kindly unmute yourself and directly interact. Yeah, Shrey has a question in the chat box window. So if you can have a look at it. Yeah. How TPM plays a vital role in automation. Yeah.
I want to ask you one question.
Yeah.
Yes, please.
Jaspreet sir, I want to ask you one question.
Yes, yes, yes.
So, I mean, you mean the predictive maintenance, right?
How TPM plays a vital role there in automation?
Is this TPM related to production management or it is, I mean, something related to process? What is TPM you mean to say?
Predictive maintenance, right? I don't know. You mean by total predictive maintenance, or what is that?
Mehtaji, what is TPM? What basically?
I mean,
Mr. Shrey, can you please abbreviate the form of TPM?
total predictive. No, I mean, normal TPM is what? Productive maintenance, right? I mean, I don't know. He's not
It is
saying
used in
it.
3 4 different sense. That's why I'm asking what is TPM here.
Yeah, correct, correct.
Shriyaji, you are able to hear us?
You are not audible, Shrey.
I think he has some network issue. Shrey, you can type in the chat box window. Yeah.
Okay, Praveen, I think next question they have typed is how effectively lean can be implemented in automation industries.
This is the same, like from Shrey only. This is the same.
Okay, the Lean Six Sigma.
Yes, I think.
Till the time TPM answer comes, we can take up the second one. That's what I was saying.
Yeah, understood. So this Lean Six Sigma, right? I mean, when they mean by lean, probably I'm not familiar with some of the terms.
Yeah, this is Lean Six Sigma, I
I
think.
think we are interacting with PhD students, so we are failure here.
No, no. I mean, we are. I mean, this is the yeah. Okay. So I believe all the factories, I mean, if you see all everywhere these initiatives are going on, right? It is there. I mean, if you ask me, automation, we are with manufacturing industry. Today, whatever I spoke about is on manufacturing industry. So if I go everywhere, I can see this, all these TPM initiatives, different things, right? Sigma, all the things. Okay, I can see this lean, and everybody is moving towards this lean production for sure. Yeah, total product TPM is that total productive maintenance only.
Total productive maintenance. Yes, sir.
So question becomes how total productive maintenance plays a vital role there in automation.
So, I mean, if you ask me the automation or in the manufacturing industry, Niranjan, can you please be quiet? Yeah, I mean, it is, you mean in the manufacturing or the industry, right? Or in automation? What is that question? Because normally these are the terms in the manufacturing or the industry, right?
Shreya again is not there.
Yeah, definitely. I believe definitely my experience when I go to the multiple customers or different customers,
He said
yeah,
yes, sir.
different initiatives are going over there, and it is there. Lean production is one of the what I'll say. Everybody is going towards the lean production right now. Nobody want extra or the inventory. They need to reduce everything. That is clear. This is my experience.
Okay, so I think we are running short of time. So
Call it.
thank you, sir, for taking up this interactive session with our participants. And now, as we are ending up this session, so I request everyone before we end to make it memorable to kindly turn on your cameras. We can have a group picture together. So I request all our speakers, Mr. Praveen sir, Jaspreet sir, then we have Pradeep Mane sir, and also Saroj ma'am. If you are hearing me,
अरे, कैप दें
so kindly
फटाफट
turn on your camera.
जल्दी दौड़ के
Thank you.
Yeah.
My baby is
आ
going
रही
out.
हूँ आ रही हूँ
So you have to stop sharing your screen. Yeah. Jaspreet sir, you are not visible. Yeah.
पता नहीं यार बाहर पई होनी जल्दी दे
Waiting.
Phone is like.
There might be some network issue. We understand. But still, if it's possible, yeah. Okay. Thank you, everyone. I have taken a picture. So see you all tomorrow. Thank you, everyone. Thank you to our speakers for taking wonderful session today. Yeah. Thank you so much. Thank you, everyone. See you all tomorrow.
Thank you.
थैंक यू
Okay. Stay
Praveen
safe.
and
Bye.
Jaspreet
Take care.
and Saroj and I think Mr. Pradeep. Anupma, should I end the meeting now?
Yes, Rishabh. Okay. Thank you so much.